Hello, good evening, Sindhamil children. கேக்குதுங்களா?
Yes, sir. Good evening, sir.
ஓகே. ஸ்கூல்ல இப்போ எந்த சாப்டர் போயிட்டு இருக்கு?
Sir, finished, sir, portion.
போர்ஷன் ஃபினிஷ்டா? ஓகே. எந்த ஏதாவது கொஸ்டின்ஸ் இருக்கா உங்களுக்கு? ஏதாவது ப்ராப்ளம் சால்விங்ல எனக்கு கஷ்டமா இருக்கு சார், இந்த மாதிரி ஏதாவது ஷேர் பண்ணீங்கன்னா we can do that. ஓகே டவுட். புக் பேக்லாம் ஒர்க் அவுட் பண்ணிட்டு இருக்கீங்களா? பேசவே மாட்டேங்கிறீங்களே, என்ன சொல்றீங்க? Which chapter you need help, or any topics which you are specifically you need some help, theory la illa numerical la? Hello. Hello, can you hear me? Hello, good evening, can you hear me? Okay. Can you hear me?
Yes, sir.
ஏன் ரெஸ்பாண்டே பண்ண மாட்டேங்கிறீங்க நடுநடுல? கேள்வி கேட்டுகிட்டே இருக்கேன், ஒன்றும் பேச மாட்டேங்குது. பதில் சொல்லுவாங்க, எனக்கு இது பண்ண முடியும். கிளாஸ் வந்து எந்த எந்த டாபிக் உங்களுக்கு ஹெல்ப் வேணும்னு சொல்லுங்கன்னு கேட்குறேன். கேட்டு 5 மினிட்ஸ் ஆயிடுச்சு. ஏதாவது டாப்பிக்கில் உங்களுக்கு சார் எனக்கு இந்த டாப்பிக்கில் ஹெல்ப் வேணும் அந்த மாதிரி ஏதாவது படிச்சுட்டு இருக்கீங்களா? எப்படி பண்ணிட்டு இருக்கீங்க? ஹலோ.
Dual nature, sir.
டுவெல் நேச்சரா? டுவெல் நேச்சரில் என்ன என்ன டவுட் இருக்குது? எப்படி தியரி தெரியல சார், இல்லை நியூமரிக்கல் தெரியல சார்? ஏதாவது கரெக்டாக சொன்னீங்கன்னாக்கா நான் அதுக்கேற்ற மாதிரி கிளாஸ் எடுக்க முடியும். தியரி தெரியுமா?
Yes, sir.
நியூமரிக்கலில் தான் ப்ராப்ளமா, டிஃபிகல்ட்டியா? ஓகே. ஸ்க்ரீன் தெரியுதா? Okay, let's try these problems. You said you have some difficulty with the for the photoelectric emission from cesium. Show that wave theory predicts that maximum kinetic energy of the photoelectrons depends on the intensity of the incident light. Kmax does not depend on the frequency of the incident light. The time interval between the incidence of light and the ejection of photoelectrons is very long. Given that the work function for cesium is 2.14 electron volt and the power absorbed per unit area is 1.6 into 10 power minus 6 watt per meter squared, which produces a measurable photocurrent in cesium. Energy absorbed by each electron in time t is given by IAT. Okay. With this energy absorbed, the most energetic electron is released with Kmax minus work function. So IAT means intensity multiplied by area, which will give me power. Power multiplied by time will give me energy, right? So that's the concept here. By overcoming the surface energy barrier or work function. Okay, Kmax. IAT is the formula, so that means I is intensity, which is this one, power by area. Area is, maybe you can take it for 1 meter square. Time exposed is mm, unit time and unit area at low light intensities when IA is less than 5 knot, no electrons are emitted. At higher intensities, when IA is greater than this, electrons are emitted. This implies that higher the light intensity, greater will be Kmax. Okay, if you are having difficulty, I can try to explain that. But power is nothing but energy by time to area. So that means what we are saying is energy E is equal to I into A into T. But since we are talking about the energy of the kinetic energy of the electrons coming out, it is taken as IAT minus work function. I naught is our work function, 2.16 electron volt or something like whatever is given there. So in a given time, given unit area, we are saying that intensity is determining the energy, kinetic energy maximum, which is the wave theory prediction. So in the case of Einstein's theory, Ke max is equal to h nu minus work function. So what this means is it depends upon the frequency, not on the intensity. Okay, so nu is the frequency. However, when they did the experiments, it was found that we cannot increase the kinetic energy by increasing the intensity. That's what they are explaining here. I think it's the same extension. So what we are saying here is the frequency is not coming into picture. So that means there is no such thing as threshold frequency. So the concept of threshold frequency does not even exist in the wave theory. That's what they are saying here. According to wave theory, the intensity of a light wave is proportional to the square of the amplitude of the electric field. Amplitude of this electric field increases with increasing intensity and imparts an increasing acceleration and kinetic energy to an electron. Now, I is replaced with the quantity proportional to E naught squared in equation 1. This means Kmax should not depend at all on the frequency of the classical light wave, which again contradicts the experimental results. I don't know what they are trying to say here. Should not depend at all. Electric field. E naught is the amplitude of the electric field. Okay. Intensity is proportional to the square of the amplitude of the electric field. Okay. time interval between the incidence of light and the ejection. So that means time interval means if an electron accumulates light energy just enough to overcome the work function, then it is ejected out of the atom with zero kinetic energy. So that means this is zero, okay. Therefore, from equation 1, time taken is phi naught by Ia by r squared. R is 10 power minus 10 because the size of the atom. Okay, phi naught is given 1.6 electron mole conversion. So what we find is we are getting something like 79 days. So that means after you expose the light to expose the metal to light, it will take 79 days for it to eject out electrons, which is what wave theory predicts, which is not the case. In reality, it is actually instantaneous process. Okay, so that's what they are trying to explain. Why we are taking zero? Because kinetic energy is zero, just to eject out. So radiation of wavelength 300 nanometers is incident. So that means 300 nanometers means I think it's something like 400 nanometers is blue light. So 300 means less than that, which means higher frequency. So I think it will be like ultraviolet rays on silver surface. Will photoelectrons be observed? Um, H2 minus work function, but they are not given any work function for silver. Hc, so Hc by lambda incident photon energy from table 7.1 work function of silver is 4.7. So energy of the photon, you can use this formula Hc by lambda. So you can do this method 6.6 into 10 power minus 34 into C is 3 into 10 power 8 divided by lambda is 300 nanometers, 10 power minus 9. So this will be in joules. I know that 1 electron volt is equal to 1.6 into 10 power minus 19 joules. So that means 1 joule, if I want to convert 1 joule to electron volt, I have to divide this by 1.6 into 10 power minus 19 electron volt. So instead of doing all these things, the easy formula is E photon is equal to, I think it's 12,400 divided by lambda in angstrom. So this will be in electron volt. What this means is all these calculations have already been done and they are given it as a simple formula for you. 300 nanometers becomes 3000 angstrom. So the energy of the photon I'm getting is 4.13 electron volt. But they said the work function is 4.7 from the table. So since this work function is bigger than this one, you cannot get any electrons. So that means no photoelectrons is the answer. Photoelectrons are not observed in this case. இது ஈஸி தான். ஃபர்ஸ்ட் இதுவாக கொஞ்சம் கன்ஃபியூசிங்காக இருந்தது. இது ஈஸி தான் நினைக்கிறேன். முடிவு சேர்த்து சின்னம் சொல்லும். புரியுதா இந்த கொஷின்? ஹரிஷ்வா, are you following this?
Yes, sir.
ஸோ த்ரெஷோல்ட் ஃப்ரீக்வன்சினா என்ன சொல்லுங்க?
Sir, the minimum frequency required for the emission of electrons, sir.
ஓகே, வெரி குட். இப்போ இந்த இந்த ப்ராப்ளம்லாம் உங்களால் பண்ண முடியுது இல்லையா? சிம்பிள் ப்ராப்ளம்ஸ்லாம் இது வேணால் ட்ரை பண்ணி பார்க்கலாம். 7.3 ட்ரை பண்ணலாமா? உங்களோட ரிக்குயர்மெண்ட் படி தான் நான் வந்து கிளாஸ் எடுக்க முடியும். நீங்கள் ரிக்குயர்மெண்ட் நீங்கள் தான் சொல்லணும். Light of wavelength 2200 angstrom falls on copper. Photoelectrons are emitted from it. Find the threshold wavelength and stopping potential given the work function for copper is 5 0. Threshold wavelength என்ன ஃபார்முலா வரும்? இப்போ தான் பார்த்தோம். Can you tell me? E photon is equal to 12,400 divided by lambda in angstrom. It will be an electron volt. So threshold wavelength na in the wavelength கேட்குறாங்க. So energy, so minimum energy of the photon should be 4.65. So do the math, you will get the answer in lambda. So that's the threshold wavelength. இந்த wavelength ஓட கம்மியா இருந்தா you will get the photoelectrons. If it is more than that, you will not get the thing. Let's see what they have got. Yeah, 2672. Something very close, right? Maybe I'm using some approximate formula here. Stopping potential K max is equal to h nu minus work function. Work function is given. K max can be written as, can convert it to stopping potential. E into V naught is equal to h nu minus work function. So they are asking to find the stopping potential. 4.65 electron volt. So this entire thing will be in electron volt. இது ரெண்டையும் கேன்சல் பண்ணோம் அப்படின்னாக்கா, so 22, if I cancel it by 2, it will be 11, 6, 2, 62. So 11 cancel பண்ணோம் அப்படின்னா 55, 5, point 55, so 7, so 70, 70 to 6, 66, 440, so 3. So this is electron volt, right, in energy. If I remove this E, it will become voltage. So it's very close to 1 volt. So I would say approximately equal to 1 volt. So 1 volt is your stopping potential. Yeah, so you can see they've done the same thing. 5.65. They have done it in a long way. As I said, you can use that shortcut method. So therefore stopping potential is 1 volt. புரியுதுங்களா சிந்தமிழ் செல்வன்?
Yes.
So இதுதான் ஒரிஜினல் ஃபார்முலா. Kmax is equal to h nu minus phi naught. But Kmax வந்து kinetic energy வந்து potential energy மாற்றலாம். Meaning you can stop the electrons. அப்போ electrons stop பண்ணும்போது என்ன ஆகும்? It will be your stopping potential E into V naught. So kinetic energy is getting converted to potential energy. இது புரிஞ்சாதான் இது வந்து உங்கள் புக்கில் ரொம்ப காம்ப்ளிகேட்டடாக யூஸ் பண்ணியிருக்காங்க. யூ கேன் டைரெக்ட்லி யூஸ் திஸ் 1 to 400 இந்த ஃபார்முலா யூஸ் பண்ணிங்கன்னா குயிக் ஆன்சர். 1 to 400 டிவைடட் பை 2200 போட்டிங்கனாக்கா இந்த இது இங்கேயே எலக்ட்ரான் வோல்ட், இங்கேயே எலக்ட்ரான் வோல்ட்டு, எலக்ட்ரான் இ கேன்சல் பண்ணுறோம் அப்படின்னா வோல்டேஜ் கிடைச்சிடும் 1 வோல்ட். ரொம்ப ஈஸி இஃப் யூ ஃபாலோ திஸ் சிம்பிள் மெத்தட். Okay, let's try this. Work function of potassium is given, so work function is given. UV light of wavelength, so lambda is given. The intensity I is given. Is incident on the potassium surface. Determine the maximum kinetic energy of the photoelectrons. So maximum kinetic energy now same formula, Kmax is equal to h nu minus phi naught. This is the energy of the photon. So phi naught கொடுத்திருக்காங்க. Again you can use the formula 1 to 400 divided by lambda in angstrom. இது பண்ணிங்க அப்படின்னா electron voltல answer கிடைச்சிடும். So it's very easy. Can you work it out and tell me what is the answer you are getting? I'll give you 2 minutes. Quick work out பண்ணி சொல்லுங்க எனக்கு answer. ஹரிஷ்வா நீங்கள் ஒர்க் அவுட் பண்ணுறீங்களா? Any answers in the children?
1.76.
1.76 வருதா? ஓகே. இதுக்கு என்ன ஆன்சர் வந்தது? எனர்ஜி ஆஃப் த ஃபோட்டான். 4.06 இந்த மாதிரி ஏதாவது இருந்ததா? இல்லை இதுக்கு தான் சொல்கிறீங்களா 1.76?
Maximum kinetic energy, sir.
ம், என்ன சொல்கிறீங்க? இதுக்கு மட்டும் என்ன ஆன்சர் வந்தது? 1 to 400. .13 minus 2.3, yeah. So 3, 3 question. 1.83. You got 1.76. I'm approximately getting 1.83. Maybe it is close enough. I don't know. Let's see. Yeah, book answer 1.83 பக்கத்தில் தான் வருது. இங்கே ஏதாவது மிஸ்டேக் பண்ணியிருக்கீங்களான்னு பாருங்கள், செக் பண்ணுங்கள். Anyhow, we can go to the next one. If 40% of the incident photons produce photoelectrons, so this is the total energy IAT divided by energy of one photon. So total energy divided by energy of photon will give me total number of photons. Intensity வந்து 2 watt per meter square. Area 2 centimeter square. So 2 centimeter square. So centimeter square na 10 power minus 2 the whole square, right? Centimeter square. Time is per second, so that means 1 second divided by energy of the photon. Energy of the photon we calculated it as 4.13. So that will give me the total number of photons. But they said 40% of the incident photons produce photoelectrons. How many electrons? So that means 40% of this will give me number of electrons. This is approximately 4 and 4. This is 0 and 0 cancels out. Again, I am doing some quick approximation calculation. So ಇದು ಒಂದು 10 power minus 5 item. So 4 into 10 power minus 5 approximately. It might be slightly higher, slightly lower, 3.9 அந்த மாதிரி இருக்கும்னு நினைக்கிறேன். 10 power minus 5. I am supposed to get a bigger number. Why am I getting lower number? Because electron volt bottom, this should be in joules இல்லையா? So I think I made a mistake here. So this should be in joules. So electron volt ಇದೆ. So 1 electron volt is equal to 1.6 into 10 power minus 19 joules. So that's a mistake I did here. So multiplied by 1.6 into 10 power minus 19. So do the math. So 10 power 1.64, so approximately 3 times, no, 660 into 4. 10 power minus 19 will become plus 19. So 19 minus 5, 14. So approximately this will become plus 14. This will be 4 divided by 1.6. So 4 divided by 1.6 is it 3 times? 6, 3, 8, 1, 4.8. Maybe less than that. So 2 point something. Yeah, around 2.42. So this many electrons will be coming out. Yeah, 2.4 into 10 power 14 photoelectrons per second. Yeah, so electrons per second I have to write. ஏதாவது புரியாமல் இருக்கா? டவுட் இருந்தால் கேளுங்க, சொந்தம் சொல்லுவோம். Fundamental one, any doubts? Any doubts? Are you following? I'm supposed to find the square root of this. Having some issues here. Let's see. Two electron mount kinetic energy is 2 into 2. Yeah, I'm doing it correctly. Into 2 into 0.6 into 9.1. This much. So square root of this is 1.6. This will be 10 power minus 40, 50, so 25. Yeah. Mm. 8.68, that is correct. So what we did was correct. So do the same thing for bullet and car. Okay, follow the same formulas. You will get the answer. Okay, any other questions? Any doubts? Okay, I will stop here. Thank you.